beam dengan lagi satu double reinforced concrete beam. So that means you can start to design for your project. Okay. Alright, so you can refer in this Euro code in section 6.1, which deal with the analysis and designs of section for the ULS, which is ultimate limit state design considerations. Okay, so make sure you find out these sections, which is it give you informations of the analysis design for the ultimate limit states. Alright, so before that you need to understand what is singly, what is doubly ataupun single, double reinforced. So we have two types beam section, which is rectangle sections, and another one is the flange sections. So I hope you already understand what is rectangle section, what is flange sections, how it become rectangles, and how it become flange sections. Okay, kalau rectangles, it should be rectangle shapes lah, which is for rectangles, it consists two types, either singly or doubly reinforced. What is meant by singly and doubly? That is singly reinforced beam, the beam that consists only tension reinforcement as a main bar. This is a tension reinforcement, okay, which is we labels as a AS, area for steels, okay, for the tension reinforcement. As we know that concrete is very good in compression, so that's why at the a certain case, we just provide AS only. We just provide tension reinforcements. Okay. Yang lain-lain macam biasalah ada links ke kan. Which is this is a singly reinforced concrete beam we call it. But for other case, when the concrete has to support higher load. Okay, once it have to support higher load, it should be provided by compression reinforcement also. Okay, so the tension reinforcement, this is very basic. It should have AS here. It should have tension reinforcements. But at the some cases, okay, when that concrete beam have to support the high load, which is the compressive concrete couldn't resist anymore. So that's why it need help from the compression reinforcements, okay, to support the extra load, to support the additional loads, to support the high load here. So this we label as a AS prime, which is represents as a compression reinforcements. Compression reinforcement. This is tensions reinforcements. So that means we have to check either that rectangle sections ataupun flange sections, either we should provide compression reinforcements or not. Depends on the load that apply on it. Okay, kalau load tak berapa tinggi sangat, so we just provide the singly reinforced beam. Okay, which is it also applied for the flange section here. Tak kisahlah T beam ataupun L beams, right? Okay, it will also have these two types here, either singly or doubles reinforcement. Okay. Okay, this stress strain diagram you have learned from the previous lecture, right? Okay, which is the stress strains block diagram is from the cut sections of the beam here, which consists of B. D is the effective depth, which is from the top surface to the center of tension reinforcement, while H ni adalah full depth. Okay, full depth for the beam. D from the top surface to the center of AS, to the center of tensions reinforcement. This is how we sketch for the single reinforced concrete beam cross sections. Okay, from these cross sections, which is a singly that only have a AS here, that we only provide tension reinforcement. This is how the strains block diagram looks like. Okay, this is strain block diagram. Okay, so remember this is where the neutral axis that divide the compressions and tensions area. Okay, the third one, which is concrete, that is very good in compression, which is this compression stress will be supported by the concrete, right? Because concrete very good in compression. It that means it um, didn't have to need reinforcement to resist the compressive stress. Okay, concrete itself will support that stresses. So that's why the top triangles one here, which is the line of strains block diagram, this is the strain for the concrete. Okay, the concrete will handle the compressive stress. Okay, for the compressions region here, with the ultimate strain of the concrete is a 0.0035. You need to remember all these strains value. Okay, that means this is start from the 0 and then kat sini lah dia punya maximum, which is 0.0035. Okay, if you want to know what's the strains value at these levels, okay, you need to know the depth here, then you can make a ratio. Okay, which is the maximum depth for concrete strain is a X here. Okay, so kalau more detailed analysis, you can come up with, symbol ni salah. This is symbol for stress. Well, this is symbol for the strain. Okay, so you can know what the strain here at this point. Okay, which is this one is the linear. Okay, it start from the 0 at the neutral axis and up to the maximum of 0.0035 strain for the concrete. Okay, then the bottom one, which is this tensile stress here, will be resisted by the tensions reinforcement. Okay, again, concrete not very good in tension, so that's why we need this kind of material, which is steel, because steel is very good in tensile strength. So that means this tensile stress at the bottom one will be carried by this steel reinforcement. So that's why the bottom triangles block here is a strain for the steels. Am I lost connections ke?
Tak ada, doktor.
Okay, saya tengah loading ni. It shows that I'm lost connection. So I continue je.
Okay, doktor.
Okay, so yang bawah ni triangles block a diagram. It shows that the strain for the steel reinforcement. Okay, so that's why triangles bawah ni, okay, which is top the same levels reinforcements. Okay. I punya slide tak ada
Doktor slide hilang.
Okay, so that is for the strain here, which is strain for the concretes. We label as epsilon concrete in compressions, epsilon cc, while for the strain for the steel, epsilon steel in tension, okay, epsilon st. So this is how you draw for the block diagram. Ni you kena practice. Okay, you kena practice how to draw this one. Okay, sometimes the question asking you to sketch the stress strains block diagram for the singly reinforced concrete beams ataupun stress strain block diagram for doubly reinforced concrete beam. You have to know all of this value, all of this label. Kalau strains concrete in compression, the maximum strain adalah 0.0035. Untuk steel, okay, strain for the steel in tension, this is the value which is 0.00217. So that means this is 0 here. The maximum one here is a 0.00217. Okay, so then this is for the force here ataupun stress. Okay, we have stress strain, so this is stress, which is stress is equal to P divided by A, which is the force here. Okay, so this stress block diagrams, okay, you also need to do exercise how to draw it, which is again it based on this neutral axis. This is the block for the compression stress, okay, which is it not fully up to the neutral axis level because it concerned about the safety. So that's mean once for the loading, we not consider that one is 100, not consider the original. Kita buat some safety here, which is we consider about 0.88x here. Okay, dia punya depth. The depth actually x from the top to the neutral axis, but for the stress block diagram, it just consider about 80% from the original stress. That means 80% from the original depth of neutral axis, which is 0.8x here. So this is the depth that will be concerns. This is the for the concrete forces, okay, which is FCC. Okay, force for the concrete, and we have the bottom one force for the steel, which is FST. Okay, force of concrete in compression, force of steel in tensions. All right. Okay, this is the ultimate, okay, ultimate design strength, okay, for the concrete, which is 0.567 FCK. I will not repeat back how this value comes from. You need to refresh back from the first slides or from the previous chapter, which is it mentions about the the ultimate stress for the concrete here, which is for the concrete is a 0. This is a coefficient factor, right? And also once we consider the safety factor from the FCK, from the strength of the concrete. So 0.567 ultimate design strength for the concrete, and then for the steel, I think is about 0. For the steels, okay, this one for the lever arm for the steel, the force for the steel, which is 0.87 FYK. Okay, please take note here. Okay, 0.567 FCK for the concrete, ultimate design strength for the concrete, while ultimate design strength for the steel is a 0.87 FYK. So this is how the stress strain block diagram for the singly reinforced concrete beam here. So this is all the notation. What is it about X? Okay, Z here. Z is the punya height from the force of the concrete, okay, to the FST, which is Z is equal to D minus 0.5S, which is Z is equal to D. D is from the concrete surface to the steel. You have to minus half of this height, right? This is S. That means half of it is 0.5 S. Ataupun you boleh juga buat Z is equal D minus 0.4 X. Sama juga kan? Ni X kan? Which is you have to minus half of it 0.4x, okay, ataupun either one lah. Yang penting that this Z is from this arrow to the steel level. Okay. Okay, from all of this value here, you can come out with equilibriums. Okay, you can come out all the forces. This is all the formula. Tension for the steels, compressions for the concretes, and also equilibriums. Okay, so remember this is the stress block diagrams. So it should be at the centroid for the FCC for the concrete. Okay, and then this is a FST. Line tak elok I punya ni tunjuk lagi that I lost connections. But from your side I'm still exist kan?
Yes, Doctor.
Okay, FSC 0.87 this one FYK untuk concrete. Aiyo. Rasa saya tutup kamera Okay, so I repeat again. I might be I lost kat sini. Okay, stress is equal to F divided by A, which is force divided by the area. So that means force is equal to stress multiply with the area. So kalau concrete, you have to multiply with the area for the concrete. Kalau steel, you have to multiply the stress with the area of the steel. So that's mean for the steel here, stress, okay, stress multiply with the area. So stress for the steel adalah 0.87 FYK. You have to multiply with the area of the steel. So area of the steel, AS, this is the AS. Okay. Tak kisahlah berapa numbers of reinforcement of tension reinforcement. So what's the AS? Total for this area for this 3 bar, 2 bars, 4 bars, depends what's the AS that you provide in these beam sections. Kalau untuk compression, so same, which is force is equal to stress multiply with the area. So sebab concrete, it should be area for the concrete. So this is the stress for the concrete, which is 0.567 FCK multiply with the area of the concrete, which is the stress block. This is the stress block of the concrete. Okay, yang ni lah. Dia punya lebar beam berapa, which is B, and then stress block area, which is this is the force only resist this compressions stress area here with the height of 0.8 X. Jangan darab dengan full depth pula. No, this force for the compressions area, this still will support the tension stress. Okay, so you will have these two FST and FCC. Okay, so that's mean there will be a apa ni, this one FYK AS, okay, for the FST. Then once you apa ni, multiply with this stress area of the stress block, you will get FCC is equal to 0.454 FCK BX. Can you understand me? Faham tak saya so far? Can you understand? Siti Mastura faham, Siti Mastura seorang faham ya. Any questions? This is very important.
Tanya, boleh tunjuk contoh untuk kira AS tak?
Okay, after this, there will be an example for the AS. Okay, kalau AS tu, contoh AS tu is about area saja. Area for this reinforcement. This is size, let's say size 20, diameter 20, right? So pi di power of 2 divided by 4, this is the area. Kalau ada 3 bar, so area for the second bar, for the third bar, this is area for the AS. Kalau nak kira, tak nak kira manuals pun boleh, ada tables. Okay, kalau you lihat dalam apa ni, groups telegram, I also attach the appendix, right? That one also you can see the tables for the bar, for the reinforcement. For one reinforcement, for one bar with the size can be size 6, 8, 10. So that give you a area for that bar. Okay, according to the number, according to the diameter of the bar. Okay. So I proceed, okay? Okay,
Okay.
so this is the formula, okay, which is this is apa ni, formula for the tension force of the steels. Well, this is FCC, it becomes FCC, it becomes 0.454 FCKBX. FCK ni berapa strength concrete? B, what's the width of the beam sections? This is X here. Okay, so which is the neutral axis, right? From the neutral axis here. Okay, then we have another one. If you make the forces FCC and FST in equilibriums, there will be a FST with the force directions to the left side, and FCC the arrow, which is the directions to the right side. So this make it as the equilibriums, all the forces. Bila all the forces equilibrium, ada dua forces je, which is FCC and also FST. So just list out the equation, each of it, for FST and also for the FCC. Ni terbalik ni. Ni terbalik kan. So boleh betulkan balik lah ni. Okay, FCC it should be 0.45. Ni should be 0.454 BX. Well, FST, this one 0.87 FYKAS. Okay, so but this is still the correct one, which is you make X, okay, sebagai dia punya apa ni title here as the unknown here, which is X is equal 0.87 FYKAS divided by 0.454 FCKBX. You don't have to remember all this formula, but just you can draft from this stress diagram. Okay, you can just from this stress diagram. Equilibrium, just make it FCC, FST, what's the equation of it, and then make it X as the unknown of the equations, as the title of the equation. From this equation, if you know what's the AS, what's the value, if it's given, what the AS, sometimes the questions give you nilai AS kan, dia bagi terus 2H 16. Dari 2H16 you dah boleh tahu dah berapa actually AS for 2H16 here. Replace in this equation. FYK dah tahu berapa steel, let's say 500. FCK, let's say the grade of the concrete is 30. B, what's the width of the beam section. Then you will know what's the X here. What's the X value, which is X is the neutral axis depth. Okay. That means from the equilibrium of the total force, you can come out with X equation. You can come out with neutral axis equations. Okay, then from the diagram also, you can come out with the formula for the moment resistance. Okay, look at of this diagram. Again, it's actually according to this diagram. We have a FCC, FST, okay, remember all of the value of it. Then you can know what's the moment resistance if respect to the steel here. Okay, you boleh calculate moment for the steels here, moment respect to the steels. So that's mean all the force brings to this steel, all the force brings to this bottom point. So for the force, it should be for the moment to calculate the moment, it should multiply between force and length kan, force multiply with the length. That means FCC, okay, calculates the moment at this point. So that means this force of FCC multiply with the Z here. Okay, which is FCC is a 0.454 FCKBX, dan dia punya Z adalah D minus 0.4 X. Okay, this is this force of concrete at the center here. So that means half of it is a 0.4 X. So jarak daripada arrow ke level of the steel here, which is D minus 0.4 X. Okay. Boleh juga 0.5S macam saya kata tadi. So mana-mana value yang mudah lah. Okay. It is 0.5S, it means 0.4X here. Okay, so from the equations, so this is how we arrange the formula. Okay, that make it this formula is equal to K. So therefore, finally, M is equal to K. K will represent for this formula. Okay, that means simplified to, as a K here. FCK BD power of 2 here. Okay, so this is how we calculate for the moments when it respect to the steel. We also can calculate the moment respect to the concrete. Okay, respect to the concrete. You buat moment dekat concrete ke, you calculate moment resistance dekat steel ke, it still will give you the same value. Okay, remember moments kan, pusing sini sama moment dia, pusing ke sini pun sama dia punya nilai moment, sama juga. FCC multiply with the Z will be equal to the value of FST multiply with the Z. Kalau respect to the concrete, that means FST will have to multiply with the Z but in these directions, okay, to this point of the concrete. So M, moment resistance, is equal to FST, which is FST is a 0.87 FYKAS. Okay, the tension force for the steels that is multiply with the area of the steels. Okay, multiply dia punya length. Length dia adalah Z, which is Z, which is D minus 0.4 X here. From these equations, once you calculate moment resistance with respect to the concrete, you will have this formula, right? You will have this AS value. Once you make it as it title, as it unknown here, okay, you can calculate what's the AS value here. Okay, which is area of tension reinforcement is equal to M, which is moment, divided by 0.87 FYKD. That means this is the area of reinforcement that you have, that you need to provide to the concrete according to the moments, according to the loads that applied on the beams. Okay. So akan ada contoh nanti. So that means, let's say the question give you this beam cross sections. Okay, so dia tak bagi pun lagi reinforcement berapa. You have to design what actually the AS that is required. This is the AS, how to calculate. This is the AS, what is required for this beam section. Let's say in order to support the moments, in order to support the maximum moment, let's say about 50 kilonewtons meter. Okay, how to get this one? It's from the beams. Let's say these beams have to support the load. Might be from the slabs, might be from the brick wall or from the concrete slabs. which is once you calculate, this is kilonewton per meter, right? So once you calculate the reactions, and then you will come out with bending moment diagram, shear force diagram. So the maximum, let's say this one, which is the maximum one, is 50 kilonewtons meter. Okay, so the maximum moment which this beam section BH, this beam section will be support this of maximum moment here. So from these sections, from this maximum ultimate moment, what the AS, what the reinforcement should be provided. So that's why you need to understand the patterns of the question. Where's this moment come from, and then from this moment, this beam section should resist this ultimate bendings moment from the bendings moment diagram. So in order to resist this maximum moment, what's the steel reinforcements area for the steel reinforcement should be provided in this beam sections. Okay. In other questions, dia dah bagi siap-siap dah. Dia dah provide the reinforcement. Let's say 2H20 is provided for this beam with dimension of B and H. So dia bagilah might be 150 H300, right? And then it consists of these 2H20 by referring of these cross sections with all the values given. What's the capacity of the moment resistance that this beam section can be supported? So dia terbalik pula. Kalau macam ni, dia dah bagi moment, beam ni perlu provide berapa bilangan bar. Size apa yang sesuai untuk reinforcement, untuk steel reinforcement untuk support this load. In other way, dia bagi cross sections dengan all the dimensions, sizings, all the numbers of bar. If these beams consist all of it, berapa the maximum moment that this beam can resist. Okay, so it can be two way of the questions here. Alright, so at the same time, to ensure that the sections designs here, okay, for the beams here, is under reinforced. So remember, we go designations for under reinforced in order to ensure that the steels can achieve its yield limit. Then after that, we continue with the concrete failure. Okay, because concrete is very brittle materials. We don't concrete fail first. We want still achieve the yield strength first. Then barulah boleh concrete tu pula untuk achieve dia punya limit. So that's why we have to design based on under reinforced. So to ensure that we follow the limit, under the limit, so EC2 suggests this limitation. So that means X, it should be less or equal 0.45D. Okay, so remember for this X here from the block diagram, this is the neutral axis, right? Okay, so that means this X, this X, it should be less or equal 0.45 D. So this is the limits that Eurocode suggests to ensure that the sections, to ensure that this beam is designed under the under reinforced. Okay, so that means for this limitation, we call it as a for the moment resistance of singly reinforced section, or we call it as a moment balance. Moment balance, that means we consider these limitations. Okay, so this is the moments, okay, from the moment resistance from the formula that we get from the equilibriums. Okay, moment resistance with respect to the steel. This is the equation of the moment. Kalau kita calculate the moment based on respect to the steels, okay, respect to the steel here, this is the equations here. Okay, so to be as a moment balance, okay, this is M, it can be moment balance, but we have to consider this limit. So that means we have to replace the X value to be 0.45D. Okay, masukkanlah this X will be 0.45D. This X also 0.45D. So just replace in the equation to make it as a moment balance, to make this equation follow the limit. Okay, so at the end, this is the equations for moments balance. Okay, which is consider the limitations of Eurocode about X is equal to 0.45D. Okay, so moment balance is equal to 0.167 FCK BD power of 2 ataupun K balance FCK. This is still the same. This is the simplifications. Which is K balance is equal to 0.167. Okay, so that's why 0.167 FCKBD power of 2 ataupun K balance FCKBD power of 2, which is K balance is equal to 0.167. Okay, this moments balance will be compared with the moment resistance. We compared with the original moment or ultimate moments that the beam will be supported. So ni moment resistance ni, this one from the from the real moment that the beam have to carry. That's mean from the slabs, from the bricks, for any loads that apply on that beam. This is the original moments. Okay, the real application of that moment. While this moments balance is according to the grade of concrete, to the beam sections that you provide, that you propose here. Okay, so that's mean it based on the sections, on the size that you propose, either can support this moment that apply on the beams here. Okay, so therefore moments is equal to moment balance is equal to K balance FCK BD power of 2 here, which is K balance is 0.167. You have to do of this comparison. You have to check this comparison, which is moment, okay, which is from the applications, okay, from the loads of the beam that apply on it. Compare with the moment balance, compare with the beam sections, beam size that you propose. Okay, if moments resistance is less or equal to moment balance. Okay, so that means you can provide, you can design just a single reinforced beam that provide tension reinforcements only. Okay, so let's say moments ni apa ni 50 kilonewtons meter. Moment balance, that means this beam section with the size that you provide, actually this section can resist the moment resistance up to hundreds kilonewtons. Okay, so moments less than moments balance, so that means you can just provide AS, just provide the single reinforcement of tensions, okay, at the tension. But if this beam sections, again, according to its size, it can support up to 100 kilonewton. But the beam that the load that applied on the beam here is quite big. That means the moment resistance about, let's say, about 150 kilonewtons meter. So that means the moment resistance that from the loads, okay, is quite big here, which is more than the beam sections, more than the size capacity of that beam can support. So that means you have to add another reinforcement to cover this 150 kilonewtons meter. So this is the principle. It should have a tension reinforcement first. Kalau load is quite big here, which is more than the sections capacity of the beams, so you have to provide additional reinforcements bar at the compressions area, which is ES prime. Okay, so it becomes doubly. So that means either singly or doubly it based on this comparison. If less than moment balance, just design for singles. If more than moment balance, so you have to design as doubles. Okay, so you also can use other comparison that use K and K balance, which is K balance is 0.167. Well, equation for the K is equal to M divides I ingat FCUBD power of 2. Okay, so we will go after this, the equation for the K. So you boleh guna moments concept ataupun equation for the K here, okay, in order to make a comparisons. K less than K balance as a single or K more than K balance is a double. So these first examples give you on how to determines either that sections as a singles or as a doubles reinforcements. Okay, so this is how the questions always looks like. Okay, kalau dia nak you provide apa ni dia nak you propose the area and numbers of reinforcement, so there will be no the section, there will be no apa ni AS here. So that means you have to design what's the AS should be provided ataupun AS primes. Okay, depends on the moments resistance. Is it less or more than the M balance? In the data, it gives you the design moment. So that means you have to design the area of the reinforcement based on this capacity. According to this 200 kilonewton moment for the designations for this moment, what the AS should be provided. what's the numbers area of the reinforcement. This is standards. FCK grade of the concrete, FYK is the strength for the steels. Okay, so that means you have to know at the first step you have to identify, is it doubly or singly for this reinforcement required according to this design moment of 200 kilonewtons meter. Okay, again, you have to moment, you have to compare with the M balance, right? In order to know M for the moment less or more than the M balance. Okay, if M less than M balance, it should be singly. If M more than M balance, it should be doubly. That means should have AS prime. AS ni of course lah. This is the basics one. Okay, so that means you have to calculate what's the M balance. M tadi dah ada, which is 200. Compare with this M balance. So just masukkan nilai, which is grade of concrete FCK. B is the beam sections, is already give here the width of the beams. Okay, and then the D effective depth here. Dia dah bagi effective depth. Okay, effective depth is from the concrete surface. From the concrete surface to the steels reinforcement, center of reinforcement. Okay, so nak tahu D ni, kalau dia dah bagi, guna je lah. Kalau tak dibagi, you kena find out what's the concrete cover. Remember, from our previous lecture, you dah cover kan berkaitan dengan concrete cover. Okay, so from the full depth, you have to minus the concrete cover and then minus with the half diameter of the bar, then you will get the D value, the effective depth of the beam. Okay, so dapat M balance here is 211.36, which is more than the M, more than the resistance, which is this should be designed as a singles. Okay, once the moments of 200 less than the moments balance, so you have to design as a singles reinforcement. Okay, so for singly reinforced sections here, okay, you can know what's the depths of the neutrals axis. Okay, what's the X here? Okay, how to know the equation? This is from the stress diagrams, right? Okay, which is moment resistance, which respects to the steel from these equations. So make apa equation ni namanya? Quadratic I pun dah tak ingat. Is it from the mathematical? So you will get these two value, either X 188 and another one X is 937. Tapi ni tak logik lah. So that's why X is equal to 188. Okay, dia punya effective depth pun effective depth is the 450 mm, right? So ni tak logik lah. So that's why you have to use of this X is equal to 188 mm. But you have to check. Limitations to ensure that they still achieve the yield strength, right? Which is X is equals to, which is less is equal to 0.45 D. Okay, so that means X divided by D, it should be 0.45 4, 5. So that's why you need to do the checkings. You dah ada X, which is 188. You ada D, which is 450. Divide it. It shows here that from the checking is a 0.42. It's within the limit. So that means okay sections under reinforced. Okay. This is the checkings. That means what you will design is based on the under reinforced sections. Okay, then you can calculate the AS that is required here. Okay, work by using of this equation. So this equation based on diagrams, right? So I reverse balik, which is this is area of tension reinforcement based on moment resistance with respect to the concrete. FST darab dengan Z, bla bla, you dah jadikan AS here, okay, as a title, as the unknown here. So this is the equation to calculate the area of tensions reinforcement. So masukkan nilai AS, masukkan nilai moment yang perlu beam support adalah 200, and then masukkan all the value of FYK 500, and then it should have a value of Z. So that's why you have to calculate the Z first, okay, in order to substitute in this equation. So Z, which is this Z here, this is a FCC. So Z adalah D minus 0.4x. So X dah ada 188. So D dah ada 450. So masukkan nilai. So you akan dapat nilai Z. Z masukkan dalam equation. So you will get the value of AS required. This AS required, which is 1227 mm power of 2. The area that you must provide, it compulsory at least according to this AS required in order to support this moment of 200 here. Okay, so 1227. How to know based on this AS required? What's the numbers of reinforcements? What's the diameter of the reinforcement? It based actually from these tables. This table also you can refer in the author, okay, from apa ni, in the learning materials for all the code of practice. There will be these tables, okay. It can be apa ni, tak ingat kat mana yang letak dalam code of practice tu, dalam Eurocode ataupun dalam BS standards. So akan ada these tables, ataupun boleh refer saja appendix yang I dah upload dalam group, dalam Telegram group tu, okay. Which is these tables that you can simply identify the area, the numbers of reinforcement should be required according to the area that you calculated. Area required 1227. So you lihatlah, this is all the area. Okay, 1 bar, let's say 1 bar of reinforcement with the size, with the diameter of 6. You boleh calculate, okay, pada power of 2, so berapa ni? Kalau 1 bar dapat area 28.3. Kalau you darab 2, you dapat 56.6. Sama juga, different size here. Okay, actually this is can be come up from the manual calculations. Tapi kalau dah ada table, you just refer table sajalah. Okay, kalau ni 2 bar untuk 6 diameter, 3 bar untuk 10 diameter. So dengan area yang you dapat tadi 1227, so you just find out which area that is close to that AS required. So in this case, it give a suggestion that this 4 numbers of bar with the diameter of 20 is a 1, 2, 5, 7. Okay, which is nearest to the 1, 2, 2, 7s. Okay, once you want to provide the reinforcement here, the area should be equal or more than the AS required. AS required tadi, we call it as the AS required. That is required to provide. Okay, 1, 2, 2, 7. Okay, so this from the reinforcement that you will provide, we call it as a AS provided. This is that you provide according to the AS that is required. So AS provide here should be equal or more than it. Tak bolehlah kurang daripada AS required walaupun 1 mm. No, it should be more than 1, 2, 2, 7. So this is the best, might be, I can say this is the best suggestions to provide 1, 2, 5, 7's area, okay, that equal to 4H20. Okay, let's say you don't want this suggestions. Kalau you buat 4H20, so it will becomes 4 numbers of bar, okay, at the tensions zone here. Okay, betul lah nak lain. Let's say this one, okay, ataupun let's say this one 520, okay, with the area of 1571. This 1571 can be accepted because it more than AS required. But you also need to concern about the numbers of reinforcement. Okay, the numbers of reinforcement. Kalau 5H, this one 5H20 with the AS that you provide is 1571. So you kena tambah lah lagi reinforcement. So might be it becomes crowded. So you have to propose the numbers of reinforcements, the diameter of reinforcement wisely according to the gap, according to the size of the beams and so on. Kalau you nak letak 7, 16, 7 numbers of bar with
哦，要我们怎么讲啊？
Okay, tabel ketiga kena tendang. Alright, so it should be AS that you provide more than the AS required. So I repeat, kalau you nak ambil 7 numbers of bar, nak ambil saiz kecil sikit 16, tapi dah jadi 7 kat sini, how you arrange for this 7th bar is will be crowded, right? Apa ni, at this area, so that's why you have to decide wisely according to the width of the beam section. So kalau dapat kurangkan size, dapat kurangkan number of bar, it will be much better. Okay, as long as AS provided should be more than the AS required. Okay, then for the second examples here. So for this example, it shows AS here. Dia dah bagi AS, tak payahlah nak cari AS. But dia mesti suruh you calculate, determine the moment resistance. Determine the moment resistance for these cross sections. Okay, if we provide AS 2H25, AS 2H25 berapa ni? 2H25, pergilah kat table. 2 number of bar, size 25 here. So that means this is the AS that provide by 2H25, 982. So this is AS 985. Okay, for the AS. Okay, so that means you have to determine the moment resistance, okay, for the steel area. Okay, for the steel area based on stress block diagram equations. Okay, so this is the stress block diagram equation. So that's why I remind you to understand and know how to sketch of this diagram here, because all the equation from the design is based on this stress diagrams. So if you make equilibriums, okay, between FCC and FST, okay, between FST and FCC, okay, you'll get off these equations, okay, which is X, the neutral axis depth here. From this equation, it gives you X value of 151, the depth of the neutral axis. Then you need to do the checkings, right? So to ensure that the X should be less or equal of 0.5D to ensure that this beam sections is designed under reinforced under reinforced designs here. So we have a balance, right? Balance design, we have under reinforced, and also we have over reinforced. So we want the design according to the under reinforced. So that's why you need to do the checking. Either the neutral axis, the effective depth is according to this 0.45 here. So masukkan nilai X, masukkan nilai effective depth here, it gives about 0.34, which is less than 0.45. That means you can proceed with the sizings, with the neutral axis, with this depth, okay, to be as a under reinforced. Okay, in case kalau tak dapat less than 0.5, what you should do? You should change the size. Okay, if you look at the checking is based on the size, is based on the neutral axis depth, it's based on the effective depth here. So that's why if once you do the checking, it gives you more than the limits, you need to change the size. Kalau tadi mungkin besarkan size ke, kan, so then you calculate back, is it okay the new size, kalau dapat under the enforce, so that means you have to follow that correct size, okay, to proceed for the designs. Okay, then from the stress block diagrams, from the formula, you can come up with the moment resistance for the sections here. You can either based on respect to the concrete or moment resistant respect to the steel, you will get the same value. Kalau tak percaya, lepas kelas ni you try lah. Okay, so you have if you draw sambil-sambil tu berlatih lah kan, cubalah buat FSD, this one for the concrete which is FCC, and then you ada Z here which is D minus 0.4x. Okay, so either FCC multiply with the Z ataupun FSD multiply with the Z, you will get the same value of 167 kilonewtons meter. Okay, jaga-jaga kejap lagi, saya rasa nak lost connection lagi ni. Okay, so that's it for single sections. Any questions before I proceed to double sections? You kena fahamkan single before we can proceed to double sections. Any questions? Ada soalan?
Tak ada, doktor.
Tak ada. Okay, I continue for the new slide on doubly reinforced concrete beams. Okay. All right. So if you look at here that we have doubly once we provide the compression reinforcement. So D here, D is the effective depth from the concrete surface to the centroid of AS, okay, to the centroid of tension reinforcement. So if we provide compressions reinforcement here, which is AS prime, that means there will be another effective depth for the compressions part, which is D prime. That is the height from the concrete surface to the centroid of compressions reinforcements here. So why we have to provide the AS prime once the loads reach the states here that the compressive strength of concrete is not adequate to take additional compressive stress. Okay, so kalau singles, this is AS, the compressive stress will be resisted by the concretes because concrete is very good in compressions, right? But once the load increase up to the state that the compressive strength here couldn't support anymore the additional stresses, so that's why compression reinforcement is required, okay, in order to take the additional compressive stress. So this section we call it as the doubly reinforced sections. So once you draw the stress and block diagram here, it means that you just need to add another strain, another force for compressions reinforcements. So this is the strain for the concrete, right? 0.0035. So that means there will be another level for strain of steel in compression, SC, steel in compression, which is that should be the same levels of centroid of AS prime here. Okay, same goes for the stress forces for the steels. There will be additional another one's directions of forces for FSC, which is force for steel in compression. This is the force for steel in tensions. Okay, so the rest still the same, but due to this additional compression reinforcements, there will be another forces FSC. So that means there will be a Z1 here. Okay, so Z1 Z1 is the length from the depth, then you have to minus the D prime. Okay, if I draw this one, this is a AS prime that have a D prime. Then we have another one, this is AS prime, then for tension is AS. This is effective depth, okay, for the AS. So Z1, that's mean the force from this from the steels here. Okay, so that's mean the D should be minus with the D prime. Okay, so that's mean it have FSC, FCC and FST. Sekejap lagi I lost lagi ni FSC. So it becomes three forces. So this is all the internal forces for FCC, FST and FSC here. Okay, so kalau steel untuk tension reinforcement 0.87 FYK, you multiply with the AS. Kalau FSC for the steel in compression, which is FSC, you have to multiply with the compression, reinforcement. Same goes for the compression and reinforcement. Okay. Buat sabar-sabar ya sebab korang. Saya kat office ni. Internet office yang sangat hebat, asyik lost connection je ni. You all okay ke? Korang?
Okay, betul okay.
Yeah. Sabar sikit je lagi ni. Okay, so that's mean we have all the forces for FSC, steel in compressions, and then we have FCC, concrete in compression, and also we have FSTs for the force steel in tension. So list out everything, all the forces, 3 forces. So then we have a ZEX for Z FCC, and also we have the new Z, which is Z1 for steel in compression. So once you do the equilibrium, you can list out all these 3 forces. So sama je, FST multiply with the AS. Kalau FSC, steel in compression, multiply with the AS prime. This is for the concrete. Okay, from the from the moments. So you can take the moments at any point. FST, if you take the moment at the steel here, so that's mean FSC brings to this point. Also FCC brings to this point in order to calculate the moment. So sama je lah, FCC kali dengan Z, FSC kali dengan Z1, dapat moment dekat tensions level here, which is this is the M value if taking moment of the tension steels. And then for design purpose, again we want the sections to be under reinforced, so which is this is the limit. So this also the limits will produce for the M's balance equations, right? So masukkan nilai, so you will get of this value. From this equation, you can make this AS prime as a equations in order to know the area for compression reinforcement AS prime. So kalau lihat dalam equations ni, okay, AS prime is equal to M minus M balance. So what is M balance? So this is M balance, right? 0.167 FCK BD power of 2. Okay, moment, the real applications of moments minus M balance, okay, divided by all of these things. Okay, so this is that's mean you can calculate the AS prime once you know what's the moment, and then you calculate what's the M balance. Okay, so this is how to come up with the equation of AS. Remember, for the W, you need to know what the AS value and also what the AS prime value. Okay, so in equation of AS, it's still the same. It's based on equilibriums, and do the limitations by replace the limitation for X and also put it in the equations of equilibrium. So at the end, you will get off this equation for AS here. Okay, if you look at of this equation of AS, which is it include plus AS prime. Okay, 0.67 ni plus AS prime. So that's mean in order to know the AS value, in order to know the area of tension reinforcement, you have to calculate first AS prime. Calculate dulu AS prime, berapa dapat AS prime, then you can continue proceeds to calculate the AS because the equation is included the AS prime. Okay, so all the label here it's apa ni familiar, right? FCK, FYK, BD power of 2 and also the Z1 here. Right, so this is how we do the checking for stress in compressions reinforcement. Sebab compressions reinforcement it have a D prime here. Okay, so the checking is actually from this strain block diagram, which is 0.0035 strain for this concrete here. Okay, with the neutral axis with the depth of X. While for strain of steel in compressions, you punya depth adalah X minus D prime. Okay, just make a ratio between 0.035 depth and also strain for the steel compression. Okay, so at the end, this is the checking for stress in compressions. D prime divided by X is equal to 1 minus strain of steel in compression divided by 0.0035. Okay, so for the design strength of 0.87 FYK here, okay, it should be reach the limits of divides by the modulus for the steel here. Okay, so at the end, once you replace FYK, and then this is steel modulus, so this is the limitations, okay, for checking compression reinforcement. D prime divided by X is should be less than 0.38. Okay, this D prime divided by X should be less than 0.38. Okay, so this is the first examples for W. Okay, so look at for the moment here. It gives okay you all. Sebelum I proceed, kalau sampai I proceed apa ni this example, I nak maklumkan satu perkara penting according apa ni for your projects. Okay. Uh, I want to make a face-to-face discussions for the project. Okay. I plan by next week. Apa ni? We apa ni have to do the face-to-face for each of the group with me. By Sunday. You all free ke Sunday? You free ke Sunday?
Tak free doktor.
Okay. I
Ada
plan
kelas,
macam
doktor.
ni. Okay, I plan macam ni. Sunday I memang free pagi dan petang. So I nak each of the groups datang bilik saya, wakil satu group at least maksimum 2 orang saja. Okay, nak datang seorang ke, tapi maksimum 2 orang saja wakil bagi setiap group jumpa saya di office. Waktu, okay, saya ini waktu antara, mungkin kita boleh split lah. Group 1 until group 5 you come to my office in the morning. Group 6 to group 10 you come to my office petang. Okay. Waktunya adalah daripada pukul 9, you take note, okay. From group 1 to group 5 you have to come to my room, start from 9 o'clock up to 12, might be 12:30. Okay, then the rest group 6 to group 10 you datang bilik saya, can be from 2:30 up to 5. Is it okay?
Okey, doktor.
Okay.
Betul.
Mungkin. Ya.
Ada kelas untuk pagi dan petang.
So dalam you punya 5 group member tu, adakah semua ada kelas? So yang
Ya, ada kelas.
ya?
Semua satu kelas je.
Semua satu kelas. Maksudnya grup awak saja ke atau ada grup lain tak boleh hari Ahad? Grup berapa?
Okey doktor, grup saya okey.
Grup okey. Grup yang tak boleh tu grup apa? Grup berapa?
10.
Grup 10
Grup 1.
Grup 1. Okey. Tak apa. I tengok dulu yang Ahad. Grup yang boleh datang. Oh dah nak lost connection lagi. Okay. So yang penting masa you datang pastikan bawa architect's drawing. It should be hard copy and also structural drawing yang you propose. Both of it should be hard copy. Okay Okay, bawa architects and structural layouts by hard copy. Okay, I think sekejap lagi memang dah nak lost connections ni. So don't forget submit your attendance in the auto system. So after this anything, so I will remind and inform in the
Ahmad.